Afternoon. I'm spot on weather meteorologist Matthew Euler, and welcome to my winter forecast. Now, this took a lot of research. I wanted to take my time this year with it. I didn't want to rush it. Um, Usually, I get my winter forecast out, kind of like middle October period, but I tell you what, I really want to take my time with this for the winter forecast. And I think what I'm going to do for this video, I think I'm going to divide this winter forecast video up for the 24-25 winter into two pieces. So we'll start with part one tonight. I think that's the way I'm going to lean. It just depends, how long it takes to get through some of these slides. So bear with me. You got to love this picture to start the video, right? I mean, if you love dogs, oh my gosh, this is just an adorable, adorable picture here to start the 24-25 winter forecast. A little snowman on the left and this cute little puppy in the snow on the right. I mean, gosh, just gorgeous. Just a funny, funny picture to start things. So let's go ahead and jump right into the winter forecast. Now, every year, every year, I take a look at winter factors. Like, what research have I done, or, like, what were some of the past winters like based on these particular winter factors? Now, if you see the blue coloring, that denotes the most significantly weighted factors that I'm taking into account for this year's winter forecast. So blue font means those are my weighted factors for the upcoming winter. So you see ENSO is one of those. We see the westerly quasi-biennial oscillation, the QBO, is another factor that's heavily weighted in my forecast. The Pacific Decadal Oscillation, the PDO, also. And then always the wild card every winter is the stratospheric polar vortex, the strength of that vortex, as well as the reflection of the strength of the vortex in the tropospheric Arctic Oscillation, the AO. There are other things in there you see in dark or black font, and those are things I'm taking into account, but just not weighting them as strongly as the ones that are in blue here. So let's kick things off and take a look. Now, this is fresh off the press, specifically this graphic on the right. Let me go ahead and get my laser pointer out so we can point out some things here as we go through the slides. On the left here, we have the official NOAA Climate Prediction Center ENSO probabilities, and this was just issued this month in October 2024. Blue tall bars indicate La Nina. The gray bar indicates ENSO neutral, and then the red bar indicates El Nino. So you'll notice here on this vertical axis on the left, we range in percent of probabilities from NOAA, their forecast, for specific ENSO phases here, right? We range from 0% chance, the very bottom here, up to 100% chance on the vertical axis. Now on the horizontal axis, we are breaking the periods down into months, all right? And we do this in chunks of 3 months. So OND on this graphic on the left is October, November, and December, those months. When you see DJF, that means December, January, and February, and so on, right on down the line, all the way up to May, June, July over here on the far right. Now I want you to notice the probabilities of each of these ENSO phases occurring. So we're in the October, November, December timeframe right now, right? So we generally are looking at just above a 70%, according to NOAA, the Climate Prediction Center, of La Nina conditions developing here in the months of October, November, December. So just over 70%. Now notice how that increases a little bit greater as we go into the months of November, December, and January. See how tall this blue bar is here, indicating La Nina? And then look what happens in December, January, and February, meteorological winter. It slightly decreases in probability back down to around 70%. 70% chance of La Nina conditions in December, January, and February. And then we really see the changes here, okay? January, February, March, JFM, those letters, La Nina chances are now down to as low as 60% probability. And now we got to start looking at this gray bar, how tall this gray bar is getting. This gray bar is situated at about 38% probability in the months of January, February, and March. Now, what about February, March, and April? So now we're getting towards the latter portion of the winter in February. Look at this. look at this, guys. We have the ENSO neutral conditions now, 51% chance of ENSO neutral conditions, which is greater than the La Nina probability in the months of February, March, and April. Now, what I like to do is just look at the trends here. All right, that's all I'm looking at here. I'm looking at the trend. So let's go down in the trends here. Highest chance of La Nina, highest probability over 70% in the months of November, December, January. Then look at the step down, look at that step down, and look at that step down in the blue bar. Okay, so there is a possibility. Okay, there's a possibility that we could see a transition from a weak La Nina down to ENSO neutral conditions by the end of this upcoming winter. Now, let's examine the graphic here over on the right. All right, so we just solely are talking about ENSO. We're looking at La Nina probabilities here. Now, if you look at the 0.0, this solid dark line right here, that is your neutral condition. Well, actually, anywhere from 0.5, positive 0.5 to minus 0.5, right in this zone here, from positive 0.5 to minus 0.5 degrees Celsius, that is our ENSO neutral conditions. Now, you will notice in looking at the dynamical averages and statistical averages of the models, the green and this magenta line, how this green line, the statistical average, is just barely touching the minus 0.5 degrees Celsius anomaly in the months of January, February, and March. This magenta line, the dynamical average of the models, that is a little bit more robust with the La Nina probability, but still at its lowest point in November, December, and January, it's only down to about a minus 0.6, minus 0.7 degrees Celsius water temperature anomaly there in the Nino 3.4 region. So you can see clearly here, the majority of the model members, all these different models, are projecting anything from ENSO neutral conditions, minus 0.4, right on down all the way to minus 0.7. And that's it. Now, this is the latest update from the IRI. Okay, so I just pulled this off earlier this week off their website. So this is fresh. If we look at the CFS V2 Nino 3.4 forecast for the upcoming winter, you see this dark dash line, which represents the forecast ensemble average, or the forecast ensemble mean, okay, of the different forecast members. Now, again, we're looking, let me go ahead and draw it out again. Whenever the lines are situated between this positive 0.5 right here and the minus 0.5 right here, that indicates ENSO neutral conditions, okay? So you clearly see on the CFS V2, the average of the ensemble members, a black dash line, clearly dips below this red line right here, the minus 0.5 degrees Celsius line, which is indicative of La Nina conditions. Now, CFS V2 is a little more robust with the La Nina, the cooling temperatures in the Nino 3.4 region, cooling water temps. It's down to minus 0.9 or so. So bottom line here, CFS V2 is forecasting for La Nina to develop from November 2024 right on through March 2025. Now let's look at some other interesting model outputs here, ENSO model forecast. Now this was issued back at the beginning of October 2024. Now this graphic on the left is what the forecast is for the sea surface temperature anomalies in December of 2024. And then we have January 2025 in the middle. And then over here on the right, we have February 2025, okay? So pay attention to this, particularly this dash line right here. This dash line right here. This represents, if it's a purple coloring, these bars are going to the purple coloring, that indicates La Nina conditions. If it's in the white area here, that's neutral conditions. And if it were to be over here in this like light pinkish color, that would be El Nino conditions. Of course, none of these models are forecasting anything near El Nino, okay? We know that's not going to happen this winter. But you kind of see some of these bars. Let me go ahead and let me see if I can just erase this here. I want to erase this so you can clearly see this, okay? Now, look at here. We're looking at the Australian Bureau of Meteorology model staying at ENSO neutral. The CANSIPS ENSO neutral for December. Now this is December on the left, remember this. The European is right there on the edge, the border of La Nina versus ENSO neutral conditions, okay? The JMA, the Japanese model, forecasting for a La Nina. The Meteo France model, ENSO neutral. The NOAA model is into La Nina territory, and it's the most robust in the La Nina territory. You kind of see the temperature departures from normal here in the bottom in Celsius. And then the UK Met Office model, that one is also in La Nina territory. Okay? So if you look at the mean or the average of all these models for the month of December 2024, and look where this dark gray box is, it's literally on the border between where they indicate they're using the minus 0.8 degrees Celsius as their reference point, the Bureau of Meteorology in Australia. But you kind of see what's going on here, okay? It's right there on that border, according to them, between ENSO neutral and La Nina. Over here on the middle graphic is January of 2025. And again, going down the list of models from the Australian Bureau of Meteorology model, which is the weakest in ENSO neutral, CANSIPS is an ENSO neutral in January. ECMWF, the European, is in the ENSO neutral territory in January. The JMA is also really in the neutral territory. The Meteo France model, neutral. The only two models in the month of January showing a La Nina are the NOAA model and the UK Met Office model. That's it. Two models. The average of all those models generally shows about a minus 0.7 degrees Celsius cooler than normal difference there in the water temperatures from normal in the Nino 3.4 region. Over here on the right is the 3.4 February 2025 forecast, and by this point in February, there is not one model, according to the Australian Bureau of Meteorology, in the La Nina territory. Okay, important to consider here when we look and develop the winter forecast. Now let's look at some additional stuff from the Australian Bureau of Meteorology. Let's first at the top look at, this is the average of the international model forecast for Nino 3.4. Both of these graphics, the top and bottom, were both issued on the 1st of October 2024. All right, so if we look over here in October, this is October in the upper left. We see this big black arrow pointing to generally neutral conditions, and that generally is the case right now. Over here in the middle, December, the average of all international model forecasts is predicting a sea surface temperature anomaly of about minus 0.8 degrees Celsius. And then over here on the right, we have a sea surface. This is over here on the right is February, everybody. Look at where the black arrow is pointing in. It's neutral. It is neutral. And so neutral conditions in late winter in February. The bottom three little half semicircles down here, this shows you the average of all the international model forecasts for what's known as the Indian Ocean Dipole, IOD. This was also issued the 1st of October 2024. Look at this over here on the far left. This is October. We're in neutral conditions for the IOD. There's your water temperature value, minus 0.3 degrees Celsius. The middle in December, we're still pointed in neutral. And then the far bottom right here, this shows in February of 2025, straight up neutral. So not much of a difference from normal as far as the water temperatures go. We talk about the Indian Ocean. In fact, most of the Indian Ocean is pretty much above normal. There's really no specific west or east Indian Ocean that's way above normal. So overall, what do we get out of this graphic? We're expecting La Nina conditions in the month of December, and then also into the month of January. We would expect La Nina, but I'm expecting a potential transition to ENSO neutral by February. And a neutral IOD, that's generally going to have less impacts on the U.S. winter weather. Now, here is another interesting, this is from the IRI model plumes, another interesting table here. This is the percent probability of ENSO phases based on IRI model plumes. This was released in October of 2024 as well. Now, look at this. This breaks it, this is a probability percentage of La Nina occurring, neutral, and so neutral conditions occurring in El Nino. Now, obviously, look at this. Very low numbers for percent probability for El Nino to occur. I'm not even going to talk about El Nino. What I am going to talk about is La Nina probabilities versus neutral probabilities. So in the months of October, November, and December, OND, we have a 47% chance for La Nina conditions and a 53% for neutral. So at what point does the La Nina officially kick in? We look at November, December, January. Now look at this. La Nina is only favored 53% to 46% for neutral. Now this gap has been closing, okay, between La Nina and neutral. And you will see in the NOAA official winter outlook, if you look at their description of their forecast, they do mention some of this uncertainty. Specifically, pretty much everybody's expecting a weak La Nina this winter, but there's a lot of uncertainty on whether and when that La Nina develops. Now, DJF, December, January, and February, again, 53% probability of La Nina, 46 probability for ENSO neutral conditions. But this one gets me the most. When we go to January, February, and March, there's a 43% probability for La Nina, but there's a 55% probability now for neutral, ENSO neutral conditions. See how it flips right here in late winter again? February, March, April, 32% probability of La Nina, and there's a 65% probability going to ENSO neutral. So this is really interesting numbers. Again, this is based on all the IRI model plumes. This was just released last week. So I really wanted to include it in the winter forecast. Now, when we have a La Nina, what happens? All right, the blue coloring on this graphic indicates cooler than normal water temperatures, and this light orangish color indicates above normal water temperatures, okay? So with a La Nina, over that cooler than normal water, you typically get sinking air motion in the vertical and a high pressure, this black H, high pressure. Air is sinking, so we're not getting much in the way of clouds or precipitation when these water temperatures are below normal like this. What happens in the western tropical Pacific? You got this black L. It's a complete difference here, right, in the pressure systems. This is low pressure in the western tropical Pacific. And this is going to be associated with rising air, increasing clouds, a lot more precipitation out here around Indonesia and the maritime continent of Australia. So if we just examine this chart, and now these arrows here represent the trade winds. Now in the trade wind belt of the Earth, the winds are going to blow in the northern hemisphere from the east-northeast. So overall, you're going to have stronger trade winds pushing the warmer surface water westward, and that's why you get above normal water temperatures out here in the western tropical Pacific in a La Nina year in general. Now, I kind of summarize things down here at the bottom with the text. We not only have to look again at the water temperatures, okay, as far as classification for the ENSO, we also need to look at how strong is this high pressure? How strong is this low pressure? We can do so by looking at the difference in pressure between Tahiti and Darwin, Australia, okay? We can look at that pressure difference, and what we come up with is something known as the Southern Oscillation Index. And that is a measure of the atmosphere's response to these cooler than normal water temperatures and these warmer than normal water temperatures. So in order to have a complete feedback process from the cooler or above normal water to the overlying atmosphere, we examine what's known as the Southern Oscillation Index, which is going to be positive when we have La Ninas, okay? Now, look at what we got going on here. So first, anomalously cool sea surface temperatures right in this area in the blue, like I mentioned, east central equatorial Pacific. I'm just kind of rehashing here with the words down here at the bottom for you to understand. Second, we have anomalously low sea level pressure over the Indonesia, the western tropical Pacific, near the maritime continent, okay? We get higher sea level pressure with a black H here over the eastern tropical Pacific. Again, we get the strengthening trade winds, those easterly trade winds, enhanced tropical convection or rising air motion. And we're really not going to lose a lot of the outgoing long wave radiation, OLR, from Earth when we have a lot of clouds. So OLR is going to be negative over this area of low pressure where you have a lot of rising air and clouds and precipitation. You get positive outgoing long wave radiation, OLR, over the central Pacific, over this cooler than normal water. Now I'm going to mention something, and we're going to go into this. Where these cooler than normal waters set up really, really matters for our winter pattern across the United States. I'm going to show you this now. After I do this, okay, let me do this first. I'm getting ahead of myself. All right, so for typical La Nina vertical circulation, okay, if you look at this graphic here on the left, the upward directed arrows indicate rising air motion, a lot of clouds, and most likely some sort of precipitation beneath these tall clouds here in the tropical waters of the Western Pacific, right? So you got rising air with the big arrow pointed up, then that air spreads up, diverges in the upper levels of the atmosphere. These two arrows are spreading apart, and then you get these sinking cells, these sinking pressure cells or higher pressure, generally over the eastern equatorial Pacific area. When we talk about the East Pacific, and then you get another rising vertical air motion, generally over towards the Caribbean. All right. So this shows you the Walker circulation, how the air rises, spreads apart way, way high up in the atmosphere, then it sinks. And then when the air sinks and hits the surface, it spreads out again, horizontal divergence. Then it rises again downstream. Where do these tropical rising and sinking air cells, where do they set up when you have ENSO conditions, La Nina or El Nino? Doesn't matter. All right, so we really have to take a look at this. Now on the right, I'm showing you the Walker circulation. This is the general Walker circulation. Generally over the cooler than normal water, okay, you're going to get downward vertical motion, sinking air motion, higher pressure. When you're out over the western tropical Pacific, over the warmer than normal waters, you're going to get rising air motion. The air is going to be less dense. It's going to be more buoyant. It's going to rise and form these clouds, the convection, and rain. Notice how Australia has a lot of rain and a La Nina year typically. Okay? Now, what happens if we look at the MJO, the Madden-Julian oscillation phases in U.S. temperatures for the winter months, December, January, and February? I am highlighting phase 4 and phase 5. Now, the orange colors on these smaller insets, these graphics up here from the Climate Prediction Center, this shows you, warmer than normal areas is orange and colder than normal areas is blue. So, I want you to realize with La Nina, you get this very strong rising vertical air motion over Indonesia and the maritime continent. That is indicative more of MJO in phases 4 and 5. Now, MJO is just a convective pulse that starts in the Indian Ocean and moves from the west towards the east. Eventually, it's going to move. That convective pulse is going to enhance this vertical lifting mechanism that's associated with La Nina. And so if you get to MJO into phases 4 and 5, you're going to really enhance between MJO 4 and 5 phases and La Nina. You're really going to enhance that rising air motion, okay? And so if we see the MJO, this is my point, my main point from this slide. If we see the MJO frequently stronger into phases 4 and 5 for this upcoming winter, it's going to enhance this vertical rising motion over the Indonesia and maritime continent area, and that generally results in mild temperatures for the eastern U.S. Look at the oranges here. Phase 4, almost the whole U.S., by the way, there's a lack of blue in phase 4 during December, January, and February. Look at this. And over here, phase 5, you only see the colder than normal temperatures across the western U.S., but in the east, it's still very mild. So I'm keeping a very close eye on this. How strong does MJO get? What are the most dominant MJO phases in the upcoming winter? Okay. If the MJO phase is really, really focused over the western tropical Pacific and right in the Indonesia maritime continent area of Australia, we're going to have a very mild winter. It's going to be constructive interference all the way. Now, where do those colder than normal water temperatures set up across the equatorial, central, and eastern Pacific? It is so big and important and huge. I don't care how you describe this. There was research conducted, okay? There's research out there. Just look this up. But first, before I go into I'm going to show you about central versus east-based La Nina. I'm jumping ahead tonight. I apologize. First, let's take a look at the La Nina temperature anomalies based on the strength of La Nina. So it's not just the fact that, hey, we may get a La Nina this winter for a little bit before it goes ENSO neutral. We also have to look at the strength of the La Nina. So I circled with this oval shape here, what we're expecting this winter is a weak La Nina, okay? I want you to look, these upper charts here indicate the 500 millibar height anomalies. Blue coloring on these upper graphics means lower than normal upper level heights, which correspond to lower than normal temperatures at the surface, usually in the winter. So if we have a weak La Nina, and by the way, let me explain this bottom. These bottom graphics here show your temperature anomalies. So if it's a yellow color or a very light, this very like almost like a, I don't know what you want to call it, a mustard color. Yellow and the mustard color indicates above normal temperatures. So for a weak La Nina, weak, that's why I circled it, what we're expecting this winter, you get below normal 500 millibar heights across most of Canada into the northern and even northern plains all the way to New England, really, with a weak La Nina. Now look at these temperature anomalies here at the bottom beneath this graphic. You see that we have slightly above normal temperatures up to the mid-Atlantic, southern mid-Atlantic. The dark, like the aqua color, indicates below normal temperatures up in the northern plains. So this is a weak La Nina. Very mild and above normal across California in all cases, really, with La Nina. But we're going to have a weak one. Now I want to compare that weak La Nina to a strong La Nina. Look how much more orange there is on this particular chart right here, okay? From the Gulf Coast up to the eastern US. Mid-Atlantic, well above normal temperatures with the deeper oranges here, with a strong La Nina. Look at your 500 millibar height anomalies. You got a huge upper level ridge extending northward into the Bering Sea, and you got this very deep trough, generally from the western Canada right down into the Pacific Northwest, with a strong La Nina. Much different 500 millibar signatures between weak and strong La Nina. Much different temperature anomalies for the winter months based on weak versus strong La Nina. So this strength of this La Nina matters. And why? Because the weaker the La Nina, the greater the probability other climate drivers are going to come in there. Other teleconnections are going to come in there and override the effects of La Nina when it's weak. If it's a strong La Nina, it's a pretty good slam dunk case here where you're going to see the trough pretty much positioned over the western portions of Canada down to the Pacific Northwest. And it's going to be mild with the ridge, generally from Texas up to Virginia and up even further north into New England. Now, what happened with the strengths of La Nina and precipitation patterns since 1950? Okay, so I wanted to show you these upper tier graphics, the first 7. 1, 2, 3, 4, 5, 6, 7. Green on these particular products on these maps indicate above normal precip for the winter months. Brown is below normal or drier than normal conditions. So with stronger La Ninas, let's just take the first I said 7, right? Yep, 7. And notice how, you do get some mixed results. 73, 74 was above normal, where you'd expect it to be drier than normal from the Gulf Coast up to the mid-Atlantic. But 88, 89, strong La Nina, drier than normal, right where we'd expect it from the southeast to the mid-Atlantic. 1990, 2000, drier than normal across the Gulf Coast, pretty much what we'd expect. 75, 76, below normal on the Gulf Coast. And then 2007, 2008, drier than normal from Mississippi, Alabama, right up through Virginia. And then 1955, 56, well above normal precip across the Ohio Valley and Midwest, Illinois, Indiana, Ohio, down through Kentucky and Tennessee, West Tennessee. But it was drier than normal in the 1949-1950 winter, generally to the east of that, from the Gulf Coast right to Virginia. And then 1998-99, it was above normal, generally in the Tennessee Valley, and below normal, drier than normal precip on the Gulf Coast. Now that was the strong La Ninas. Now let's look at the weak La Ninas, which starts with 1954-55. Drier than normal, but just barely drier than normal across Virginia and the Mid-Atlantic. Not a very strong dry signature in the 54-55 winter season with a weak La Nina. 71-72, you're wetter than normal. 2000-2001, drier than normal. And then 1964-65, you're near average. 83-84. Look at the 83-84 weak La Nina, and look how above normal the precip was from Louisiana, Mississippi, Alabama, Georgia, Florida, right up through the Carolinas, Virginia, eastern Pennsylvania, Long Island, all the way up to Maine. And then 74, 75 is kind of here at the bottom left. Hopefully you can see it. Green, well above normal across the mid-Atlantic. My point is there are differences between stronger La Ninas, and the signature is much more robust as compared to weak La Nina winters as far as the wetness, the above versus the below normal precipitation characteristics. All right, so strength matters, okay? And I really emphasize the importance of that. Now, one other thing really matters, and this is the source of this, okay? You can basically, I don't know, maybe pause this video on YouTube and maybe try to type this in. Just type in Google Central versus East-based La Nina, and you will get some research articles that have been released. Okay, now, what I'm showing you over here on the left is the difference, okay? We're looking at sea level pressure on these two left-hand circular graphics. Over here on the right, we're looking at 300 millibar height anomalies. All right, so we're looking at Eastern Pacific-based La Ninas in the top two graphics and Central Pacific-based La Ninas in the bottom two graphics. Now, how did the researcher determine Central versus East-based La Nina events? Okay, he used the 150-degree west longitude line, and if your coldest temperature anomalies, water temperature anomalies, are to the east of the 150 degrees west longitude line, you have an east-based La Nina. If the majority of your sea surface, colder than normal sea surface temperature anomalies are west of 150 degrees west longitude, you have a Central Pacific-based La Nina. I'm showing you this comparison of the differences here between Eastern Pacific-based La Nina, which shows generally average sea level pressure here in the upper left for the U.S., much of the U.S., and then we go down here and look at a Central Pacific-based La Nina, and we got a little bit of a different story. We got sea level pressures which are generally correlating to 95% of being above normal, right off the southeast coast. This red coloring indicates 95% probability of higher than normal sea level pressure. Okay, these are where your huge upper level ridges are located, okay? So there's a difference right there for the U.S. weather, just simply the sea level pressure. Near average sea level pressure with the Eastern Pacific-based La Nina, and above average sea level pressure with the Central Pacific-based La Nina along the eastern seaboard. Look over here, these right two graphics here, stack one on top of the other. 300 millibar heights. Red indicates higher than normal heights, 90%, 95% probability, and then the green is below normal heights. Okay. So if we look at the Eastern Pacific-based La Nina, you really don't have very strong height anomalies, generally average height anomalies at 300 millibars at the jet stream level. And if you look over here in the bottom right, with a Central Pacific-based La Nina, you have a 95% chance of higher than normal height anomalies at 300 millibars. Okay, so this is a big difference. All right, so what we're saying is Central Pacific-based La Ninas, where those colder than normal water temperatures are west of 150 degrees west longitude, they're along the equatorial areas of the Eastern and Central Pacific. It makes a big difference. In the Central Pacific, you have, with the Central Pacific-based La Nina, you have higher than normal sea level pressure, and you also have higher than normal, you have upper level ridge, generally the southeast ridge, in control with the Central Pacific-based La Nina. It's just unbelievable how this works out. And again, you can look at this article yourself. It's a real interesting article on where the coldest temperature anomaly set up with La Ninas. And so in summary, central-based La Nina events where the coldest water temperatures are west of 150 degrees west longitude favor warmer temps in the eastern U.S. in the winter. Eastern-based La Nina events favor colder temperatures in the eastern U.S. during the winter season. And it all comes down to the vertical air motions across the tropical Pacific. It all comes down, look, it all comes down to this. Where is your rising air cells and your sinking air cells in the vertical? It's going to have downstream effects on the U.S. weather. What happens in the tropical Pacific in the winter specifically really makes a difference whether we're talking ENSO or whether we're talking the Madden-Julian oscillation phase. Now, if we look and examine these top three graphics are the 500 millibar height anomalies. Blue and purple is well below normal height anomalies at 500 millibars associated with much colder temperatures and unsettled weather. Yellow indicates upper level ridges, higher than normal height anomalies, fair weather, okay, milder temperatures in the yellow colors. Bottom three down here are showing your surface temperature anomalies based on the different flavors of La Nina. Now, what happens now? I want to make one more point. I want to explain to you what hybrid La Nina is. Some people call it a mixed La Nina. Now, let me draw it out for you. Okay. So to get the mixed or hybrid La Nina, let me just do a vertical line here. This vertical line, by the way, represents my 150 degree west longitude line. Okay. This is a 150 degree west longitude line right here. So degrees west. All right, now let me change the color here. I think I should do that. Let me see if I can figure this out. Okay, yeah, right here. Okay. All right, so a hybrid or mixed La Nina event is when the water temperatures, the colder than normal water temperatures associated with La Nina, basically your 150 degrees west longitude line is going to divide this area of below normal temperatures evenly. Like basically your coldest sea surface temperature anomalies are basically equal to the east and to the west of this 150 degree west longitude line. So it's important to look to see what the forecasts show for where these colder sea surface temperature anomalies exist. So when you have a perfect balance here where the colder than normal sea surface temperature anomalies in Nino 3.4, if they're centered on that 150 degree west longitude line, that is called a hybrid or mixed La Nina, okay? I wanted to get that out there so you understood what that meant. Now, let's move on here. With a Central Pacific based La Nina, where the colder than normal water is to the west of 150 degrees west longitude, from 150 west basically to the date line, 180 degree west longitude, you generally have below normal heights, this blue shading across western Canada into the northern plains. And it's generally above normal heights from Texas right up the eastern seaboard, right through Virginia and all the Carolinas. That's a mild 500 millibar look. And the bottom underneath that shows what these temperatures were in those particular winters. Okay, and yeah, it was well above normal in this orange shading from Texas, Louisiana, the deep south, southeastern U.S. up through Tennessee, the Carolinas, Virginia, northward to PA, up into New York State, even up to Boston. The green or aqua colors indicate below normal temperature. So you see where the focus was under the trough with a Central Pacific based La Nina. Now with a hybrid or a mixed La Nina, your colder than normal temperature anomalies are generally situated, first of all, they're much lower. So we have a stronger trough over Western Canada with a hybrid or mixed La Nina event, which I showed right here. And then the air temperature anomalies, the surface temperature anomalies are still milder than normal, okay? All the way from Texas up to Pennsylvania. Cooler than normal temperatures focus themselves on eastern Montana and the Dakotas. See that? And also along the Pacific Northwest, you have below normal temperature anomalies. Now, but notice the shades here. They're not as orange as a Central Pacific based La Nina. See how orange this is on the left compared to this in the center? All right, and then the Eastern Pacific based La Nina, look at the difference here. Now, your troughing nature, the nature of the troughing extends from Western Canada all the way to Eastern Canada, so and up through the Northern Plains. So this is no longer just with a Central Pacific focus. You've got your troughing specifically over Western Canada and into the Pacific Northwest. With a East Pacific based La Nina, look at this. You got some of that focused near Hudson Bay, all right? And notice you have near average height anomalies with a Eastern Pacific based La Nina for the deep south to the mid-Atlantic as compared to above normal height anomalies here on the left with a Central Pacific based La Nina. So this really makes a difference. Look at these temperature anomalies here on the bottom right with the East Pacific based La Nina, where your coldest water temperature anomalies are to the east of this 150 degree west longitude line. Look at this. Well below normal up in the northern plains, Minnesota, Wisconsin for the winter. Colder than normal Illinois, Iowa, the Ohio Valley, Michigan, up to New England even. New England's below normal with the Eastern Pacific based La Nina. You just wouldn't think anything of this, right? Unbelievable what, a little research does. Now, if you have a weak, which we're expecting the weak La Nina this winter, okay? If it went as strong as moderate, which we really don't see that happening right now, but let's just throw it up there anyway. A weak to moderate hybrid or East Pacific based La Nina. Look at this. What I did is I just blew up. The chart here, a hybrid La Nina here, and I also blew up the Eastern Pacific. Basically, these graphics, these two in the middle and the far right, are blown up on this slide so you can see it more clearly. And you see all the different years this occurred, okay, from December to March. You got 1964, 65, 70, 71, 1974, 75, 2020, 21, just as recent as 2020, 21, and so on. There's a lot of years here is what I'm saying. And so you see where your below normal height anomalies are. They're over the northern plains and just south of Hudson Bay in Canada, extending to eastern Canada. Almost the whole country of Canada is below normal in heights with trophiness. You got an upper level ridge extending northward over the Aleutians, okay, to the Bering Sea. All right, with a weak to moderate hybrid or Eastern Pacific based La Nina. And look at this over here. I mean, look at this. Near normal is the white color for your air temperatures for the winter months. Below normal, all up in the northern plains and up to New England again. And look where your warmth focus is on the desert southwest. So, again, this really, really matters when we put these winter forecasts together. Let's look at the latest average sea surface temperature anomalies. This was from the Monday, the 21st of October 2024 brief from the Climate Prediction Center, their ENSO brief. This from 22 September right to 19 October of 2024. Blue is below normal water temperatures, so there it is right there. You see your legend here in the degrees Celsius here. And you see above normal water temperatures in the oranges, and the bright oranges is 1 degree Celsius above normal, and so on. But I circled where the La Nina, the cooler than normal water temperatures are. Now, look at where 150 West is right now, right? Now, and this is where I'm torn right now, everybody. I'm really torn on this. This is your 150 west line, that blue vertical line. Okay, that looks awfully close to a hybrid La Nina, if you ask me. All right, but if you want to really look tight, squint your eyes at this image. Maybe you say that the majority is still over here east of that 150 degree west longitude line. But I tell you what, you draw that vertical line for the 150 degree longitude line there, and I tell you that's pretty doggone close to where your sea surface temperature anomalies are centered like this, okay, on that 150 degree longitude line. That would indicate a hybrid La Nina or a mixed La Nina this year, which would favor what? Hybrid La Nina would favor milder than normal temperatures. It would, but they wouldn't be as mild as, say, a Central Pacific based, and they wouldn't be as cool as the Eastern Pacific based. So I'm kind of torn. I want to see how this plays out. Where these colder than normal water temperatures play out. I want to see this. Now, here is the NMME model forecast for sea surface temperature anomalies. Now, let me do this now. I get my laser pointer back out. Okay, so for the months of December, January, and February, look at where your below normal water temperatures are here across the eastern and central equatorial Pacific with La Nina. Okay. Now I'm going to draw the 150 west degree longitude line. I'm going to do it, guys. I'm going to draw it. All right. Let me see if I can draw it out here. The 150 west longitude line is generally going to be right here. Isn't this close to a hybrid or a mixed La Nina? Look at how this longitude line basically splits in half these colder than normal temperature anomalies in December, January, and February. Now, you might, again, if you look hard and close, you might see that the water temperature anomalies, the coldest anomalies are majority are to the east of this line still, indicating the east-based La Nina. But, I mean, this colder than normal water is not forecast to be up against the South American coast way over here. So that's really interesting. Now let's look at the image on the right. This is the NMME model forecast for water temperature, sea surface temperature anomalies, SSTs, for the months of January, February, March. Now I'm going to draw the 150 degree line one more time for you over there on the right, and let's compare and see where those water temperature anomalies are in relation to it. Okay, so I'm not going to go as far up this time. I'm just going to split it right down here. Okay, now in that case, it looks like the majority is over here in the East Pacific based La Nina. for the months of January, February, March. So this is a real tricky forecast if we judge, our forecast. We know it's going to be weak La Nina, but where do these colder than normal temperature anomalies set up? Is it a mixed or hybrid La Nina or an Eastern Pacific based La Nina? I don't see it being a Central Pacific based La Nina. I just don't see it. I see it being as hybrid mixed, maybe for the beginning of the winter, transitioning to more the East based Pacific La Nina as it kind of wanes and becomes ENSO neutral. So, real tricky stuff. Other things we have to consider when we talk about the winter forecast is this Atlantic Multidecadal Oscillation, AMO. Now, research has been conducted. It was done in the Journal of Climate, okay? And basically, we're looking at this area right here, the graphic on the left. Notice how the water temperatures are well above normal south of Greenland. This is the area they examined in this research article, the positive phase, the AMO. This is what it looks like. It's well above normal sea surface temperature anomalies south of Greenland. So let's look at what's going on right now. As of 21 October, you see this black, I did the black oval here to really emphasize where we're looking at, to see if we have a positive Atlantic Multidecadal Oscillation, AMO, and we do. You clearly see it from the research paper and what's going on right now. So as of right now, we have a positive AMO in place. Now, why do we care about the North Atlantic water? I mean, really, how does that impact me here in the central U.S., as an example? Well, the AMO can drive the NAO phase, the North Atlantic Oscillation phase. Now, with a positive AMO like we're seeing right now, that typically equates to a negative North Atlantic Oscillation regime. This was research conducted by Gastineau and Frankengool 2012, as well as Hodson et al. In 2014. That's where I got this information from their research, the two research papers here, the two groups. So this would favor a negative NAO, which means that you're going to have why is a negative NAO? Why do we care about it? Because guess what? We're going to have a huge upper level ridge then in the North Atlantic like this, and that's going to result in a blocking pattern, okay? And we're going to have a trough in the eastern U.S. like this. So your storm systems, I'll just abbreviate it with the letter L here for low pressure. Your storm systems, if they form along the coast, they're not going to be able to go out to sea towards this upper level ridge, okay, the higher heights, because low pressure follows the path of least resistance, which is towards other low pressure areas. So you're going to see a lot more coastal storm activity if you have a negative NAO, okay? It's much warmer up towards Greenland, underneath the ridge, and so forth. So that's why we talk about this as a potential factor. Now, it's not a weighted factor that I'm going with this winter. Here's the overall examples of how the AMO has changed from 1856 right on to the year 2022. I didn't quite go out to this year, but you see how there's periods of negative AMOs from 1900 to about 1925 in this blue coloring here. You notice another period of negative AMO, generally in the 1960s right through the 1970s and 1980s. Even into the 90s, it was well on the negative side of the AMO. Now, the red spikes indicate positive AMO phases. So you kind of see there's a cycle here, right? We go back to 1856, and we go out all the way to the early 1900s. We had a positive AMO. Then we went negative for a little bit, for about 2 decades. Then we went positive again. Then we went negative again. And now we're positive again. So in general, the most recent trend in a positive AMO during the 2000s is when it really started going. The colder eastern winters of the late 1970s, by the way, actually saw a negative AMO, those prolific late 1970s winters, with more of an influence from a strong positively PNA pattern or upper ridge over the western U.S. Another factor, and this is more strongly weighted in my forecast, is the quasi-biennial oscillation, or the QBO. Now, we are expecting a westerly QBO this upcoming winter. Westerly QBO basically means that we have westerly winds in the stratosphere over the equator. And surprisingly enough, just the wind direction in the stratosphere over the equator can really tie in with other teleconnections. And in this case, the westerly QBOs generally promote a stronger stratospheric polar vortex during the winter, westerly QBOs. And so this alone, just QBO alone being westerly, would promote warmer than normal temps across the eastern U.S. this winter. The graphic here at the bottom is from Singapore, radio sound observation, RAOB, showing the blue line on the positive value side of this vertical pressure line here, millibars. So you clearly see the blue line is to the right of the millibar pressure line in a positive value territory, and that's a westerly QBO. Now, if we look at the westerly QBO, okay, we're looking at the 500 millibar geopotential heights in meters, the anomalies over here on the left. Look what happens with the westerly QBO. You get well below normal heights across Western Canada and the northern plains, the Pacific Northwest. And the green coloring here on the graphic on the left, that indicates above normal heights, generally over the southeastern U.S. up to the mid-Atlantic. These are some of the factors that NOAA looks at when they create their winter forecast. How have the past years done with westerly QBOs? And we've got one this year. So we're going to check and see how the atmosphere responded to westerly QBOs over the U.S. Over here on the right, we show the temperature anomalies for the winter months, December, January, and February, and March. And look how mild things are, above normal in the yellow coloring here. Gulf Coast up to the mid-Atlantic, even up to PA and New York State. Below normal is the blue out here in Montana and the Dakotas with westerly QBOs. So don't take any other factor into account, but a westerly QBO alone promotes this kind of upper air pattern, southeast ridge, trough over the western Canada and the northwestern U.S. You also have a strong upper level ridge, generally south of the Aleutian Islands when you have a westerly QBO. So this is all connected, but for right now, just think QBO alone, this is the result you usually get in the winter. Now, if we were to combine the NAO, the North Atlantic Oscillation, and a La Nina, it's huge. It's a huge difference here. So we're showing you, in this case, the plus symbols indicate above normal heights, the blue areas, the minus symbols indicate below normal heights. If we have just La Nina alone here in the upper left, okay, just pay attention to this graphic in the upper left, A. We generally have above normal heights across the Gulf Coast up to the mid-Atlantic, right, off the southeast coast. We have below normal heights generally in northwestern Canada, right on down in northwestern U.S. We have positive heights in Building Ridge, generally south of the Aleutians, okay? That's with just La Nina alone. Now, if we take La Nina plus a positive NAO, that is just enhanced. They work together here and produce just very strong above normal heights across the southeastern U.S. to the mid-Atlantic. So very mild conditions with that positive NAO plus La Nina across the southern U.S., Gulf Coast, right up through the eastern U.S., mid-Atlantic included in that. Now, if we look at a positive NAO here in the upper right, that generally is going to result in above normal heights, milder temperatures from central Canada right southeastward to the Midwest and to the East Coast. And if you look at the bottom right here, we're showing you La Nina plus a positive NAO. It is just, yeah, like I said, La Nina plus a positive NAO, it's just a completely different game. So I wanted to show you the combinations of that. Now, with the AO, let's just look at the Arctic Oscillation, the AO with La Nina in specific winters. When you get a negative AO during a La Nina winter, look at the greens and the aqua colors. This indicates below normal surface temperatures. The warmest temperatures are the yellow out here, that mustard green over the southwestern U.S. with a negative AO and La Nina. But if you flip the AO to positive with the La Nina, again, it's an enhancement similar to the NAO. You just get well above normal temperatures all winter from the Gulf Coast up through the eastern U.S., Virginia, up to New England. The coldest temperatures are in the green out here across the northern plains, Montana, and Pacific Northwest with the positive AO in La Nina. What about the Pacific Decadal Oscillation, okay? Now, a negative phase of the Pacific Decadal Oscillation, the PDO, is associated with cooler than normal water temperatures off the western coast of the U.S., and you have very much above normal water temperatures east of Japan across the Northwest Pacific. That's a negative PDO, and we have no indication but to say the PDO is forecast to be negative for this upcoming winter season. And there it is. This blue vertical bar says it all. Since 2020, 21, it's still pretty much like this. We have a negative phase of the Pacific Decadal Oscillation. The D stands for decadal because Look at the patterns of how, it flips from positive with the red bars to negative with the blue bars. And it's over the course of decades. This isn't just like, hey, it's here this winter, it's gone the next. These phases tend to lock in for decades. So with a negative PDO phase forecast for the upcoming winter, this would promote an upper trough across the western U.S., the coolest temperatures in the west, and a downstream ridge over the eastern U.S., milder than normal temps for the east coast. Now, what happens if I take the PDO and I combine it with the PNA? There's a huge correlation to this per research. A positive phase of the PDO would correspond to a positive PNA pattern, which would favor troughing and colder than normal temps in the winter over eastern North America. But we don't have that this winter. I bolded what we have and are expecting the negative phase of the PDO to continue. Now, this corresponds to a negative PNA pattern. And what does that negative PNA pattern mean? It means we have lower than normal heights in the upper trough across the western portion of North America with an upper ridge over eastern North America, including the eastern U.S. So a negative phase of the PDO generally favors a milder than normal winter across the eastern U.S., specifically this Gulf Coast up to the mid-Atlantic. Again, PDO, decadal variability. This was an article by Gay and Luo in 2023. This is a pretty recent research paper. They said decadal variability of winter cold extremes over eastern North America is mainly tied to this PDO. And we're not looking at a positive PDO in this case, okay? We're looking at a negative PDO, all right? So when we look at Pacific North American pattern, it's a prominent mode of planetary scale atmospheric variability over the North Pacific Basin in winter, and is closely related to the strength of the Aleutian low and to the PDO. And this was research done by Lattif and Barnett in 1996. So there is connections here. Here it is graphically. I'm not even going to show you a positive PDO because it leads to a positive PNA. Cold and stormier in the east when you have a positive PDO with positive PNA. I'm not even going to go there because that's not what we're expecting this winter. What we are expecting this winter is a negative PDO to continue, and that generally leads to a negative PNA type pattern. You have the colder sea surface temperature anomalies there in the Northeast Pacific and the Gulf of Alaska with this negative PDO. You get very cold and stormy conditions across the western U.S. Severe cold stays well up to the north over the Yukon territories and northern Canada. The yellow line here represents your jet stream. Look how far north your main polar front jet stream axis is. When you have a negative PDO and a negative PNA pattern, you have upper level ridging and warm and dry conditions all the way from Texas through Louisiana, the Gulf Coast, Florida, northward into the Carolinas, Virginia, and it's just warm and dry. So I want you really to take note of how the upper air pattern changes when you take the positive PDO leading to the positive PNA versus the negative PDO and the negative PNA. All right. So we are expecting the negative phase of the PDO. And again, this is important because it generally promotes troughing over the western U.S. The combination of La Nina and that negative PDO favor an upper trough over the Pacific Northwest this winter with warm, dry conditions for the eastern U.S. When we talk about the PDO now in the ENSO phase, we want to really focus on this last bullet during La Nina because that's really what we're expecting this winter. With a La Nina winter, the Aleutian low pressure is weaker than average during winter, and that favors that negative PDO pattern because your synoptic pressure gradient is not as strong. You get weaker southerly winds along the U.S. West Coast. So PDO and ENSO, specifically La Nina and PDO in this case, do tie in together. La Nina years, Aleutian low pressure weaker. You have less strong, the winds are weaker from the south along the U.S. West Coast. And you really can't do much about those below normal water temperatures along the West Coast in this case. All right, so I'm not doing two parts. I got on a roll here, and I'm going to finish this off now. Final thoughts for my 24-25 winter forecast. We're expecting a weak La Nina, specifically for December and January. Now that's going to favor milder, drier conditions from Virginia right on down to the Gulf Coast, really, including all of the southeastern U.S. A milder and drier winter. Now, if ENSO neutral conditions were to develop like what I was showing you with some of the modeling at the beginning of this presentation, we get ENSO neutral, let's say, to develop by early February, that could alter the month of February significantly. If the La Nina holds all winter, there's a good chance we're going to see a mild winter generally. We will see cold shots, but we do expect the majority of the winter to be above normal for the mid-Atlantic, Virginia, southeastern U.S. But again, if enso neutral were to develop by early February, February could turn out to be a surprise colder than normal month. As I mentioned, the La Nina strength will be weak. It's going to result in less robust La Nina signals. In other words, other climate drivers or teleconnections could favor shots at colder air masses at times for the eastern U.S. with a weak La Nina. It can easily be overpowered, is what I'm getting at. Now, the location of cold to sea surface temperature anomalies is so important. If it's centered on or just east of 150-degree west longitude line, we either have an east-based or a hybrid mixed La Nina case. And we already examined what happens with your 500 millibar height anomalies and temp anomalies during the winter when it's east-based versus hybrid or mixed. Now, negative Pacific decadal oscillation, the PDO favors mild temps upper ridging over the eastern U.S. with the coldest temps and troughing over the western U.S. Westerly QBO, that's going to promote a stronger stratospheric polar vortex and a lower probability for sudden stratospheric warming events during the winter season. Now, it's not a guarantee, right? Like the atmosphere is got so many perturbations and things going on. This could change, I'm just going off of research in my forecast here. So westerly QBO, stronger stratospheric polar vortex, and there's a lower probability. Not a zero probability, just a lower probability for sudden stratospheric warming events during the winter season. And if this is the case, a stronger than normal stratospheric polar vortex, it's going to favor milder temps across the mid-latitudes and a stronger west to east polar jet stream. The Arctic Oscillation, the AO, is going to remain positive with that stronger polar vortex for the majority of the winter. Due to that, it's going to favor milder temps across the mid-latitude. Positive AO, stronger than normal polar vortex, that keeps all the Arctic air locked up over the polar areas. The combination of a weak La Nina and a more robust MJO, if we were to get a more robust or stronger MJO into phases 4 and 5, it's going to favor even milder temps across the eastern U.S. at times. We'll have enhanced rising air motion over that maritime continent, Indonesia area, and that is not good if you want winter weather in the eastern U.S. Now, other things to note here, my final thoughts on this winter forecast. Previous studies have shown MJO phases 2 and 3 are followed by the positive AO phase. Phases of the MJO phases 6 and 7 are followed by a negative AO phase. So really the the Pacific's going to play huge into the winter and what happens. But generally, we look at these rules of thumb here. Positive versus a negative AO. Positive AO, warmer temperatures in the east. Negative AO is going to be colder temperatures in the east. So watch the MJO, watch what phases it goes into. It really matters. Now, that negative Pacific decadal oscillation, the PDO, is going to favor upper troughing over the western U.S., more specifically the Pacific Northwest, with downstream upper ridging into the eastern U.S. this winter. This favors mild temps this winter in the east. And overall, this is what we're expecting. Above normal temps, 1 to 2 degrees Fahrenheit above normal. Drier than normal conditions for December and January across southeast Virginia and the mid-Atlantic. Again, when it comes to the temp anomalies, the precip anomalies, if La Nina persists all the way through February, then the month is going to be influenced by the southeast ridge. Usually the back ends of La Nina winters are generally much milder than the beginning. But in general, if we get, and so neutral conditions develop again by early February, then that month is a real wild card in my opinion. The winter could close out colder and wetter than normal across the mid-Atlantic and the east as a whole, but that really is going to be dependent if La Nina wanes by early February. So due to a weak La Nina, we're going to expect average to slightly below average temps in December. Usually during La Nina winters, we see cooler than normal temps in December across the mid-Atlantic and east. And then January is more of a transitional month. We have colder temps early in the month in the east, followed by milder temps later in the month, leading into that milder or above normal, the southeast ridge in February with La Nina. The storm track is primarily going to be across the Ohio Valley with a lot of inside runner type tracks with this La Nina in place. So this is going to place Hampton Roads, Virginia cities and the mid-Atlantic generally in the warm sector of many of these storms. In a lot of cases, liquid precipitation over frozen, outside, of course, of the higher elevations. So in summary, breakdown of my weighted factors in blue: weak La Nina, milder, drier than normal winter. Although that could be again overpowered by other teleconnections, so we'll keep an eye on that. Westerly QBO, that's going to favor milder, drier than normal winter, stronger stratospheric polar vortex. The PDO, negative phase of it, favors mild, drier than normal winter for the east. There's your stronger stratospheric polar vortex, and positive AO for the majority of the winter is going to favor a milder, drier than normal winter. And these are my maps to end this winter forecast presentation. This purple line represents the average polar front jet stream position. The red letter R represents ridges, where ridges are, and the blue T represents where troughs are. So you see the overall pattern here. This blue line is your jet stream, polar front jet stream. So southeastern U.S. up to the mid-Atlantic, pretty much influenced by ridging for the winter. There will be occasional progressive nature to the pattern where you get troughs to move in, but I'm thinking the troughs are really going to focus in over the Ohio Valley and Midwest, and another trough over the Pacific Northwest. You will have a little bit of ridging over here over the southwestern U.S. And then I have this red arrow for the storm track right here inside runners, right up west of the Appalachians towards the Ohio area. Here's the forecast map for the winter, December, January, February. Temperature anomalies overall, colder than normal Pacific Northwest, normal over a lot of the northern U.S. and Midwest, and also normal up in eastern Canada and New England. Anywhere below this red line is warmer than normal, from Southern California through Texas, up through the Mid-Atlantic, including you in Washington, D.C. and Baltimore, above normal winter temperatures. And then this is my precip anomalies forecast, above normal in the trough, there, the persistent trough in the Pacific Northwest, below normal Southern California along the southern U.S. up to southern Jersey. A normal precipitation in the winter for New England as well as the northern and central U.S. I am expecting another area of above normal precip there in the Midwest, Iowa, Illinois, Indiana, and Ohio, as well as extending south a little bit towards Missouri and Kentucky. Finally, the forecast map for snowfall anomalies above normal, up towards the higher elevations, Montana, Idaho, below normal in the Sierra Nevada this year, California. Normal snowfall across the northern plains, central U.S. We do see an above normal snowfall there across Iowa, Illinois, Indiana, into Ohio, right in this area, with the troughing there. And then below normal snowfall pretty much across the Carolinas up through Virginia, including D.C., all the way up towards Philly. Normal snowfall, though, for you up in New England. So if you live up in New England, you're looking at a near normal temperatures, near normal precip overall, and near normal snowfall, but below normal snowfall across a lot of the mid-Atlantic here. All right, that wraps up my winter forecast. I decided just to knock it out tonight. I was going to do a part one, but I said, let's go for it. That wraps it up, everybody. I hope you enjoyed this presentation, and I'm going to end right here. Plenty of more to come. I'll be doing more of my teleconnections videos in the weeks to follow, so stay tuned for that. And now that we are over an hour long, I am going to wrap things up. Everybody, take care and God bless. Have a wonderful, wonderful evening.